Additive manufacturing has been around for over 20 years. In the past, the additive manufacturing tools were fundamentally made for prototyping. They were made to make functional shapes to show what the shape of the ultimate part might look like. What has happened in the last 15 years, or less actually, is a development that has taken it from its fundamental application in the area of prototyping to actually factory floor final parts development. This is where we run into some issues that have to be addressed, and this is why the Aerospace Corporation has chosen to get involved at this optimum time to see what we can do to make sure that transition from prototyping tools to actual tools that might be used to make parts for our customers work. So process controls is what's now being a focus of the research of the next gen tools that are going to come online, which is to ensure that as you're making a three-dimensional part, actually is defect-free and you don't have to cut it up to check it.
So we're working on expanding our capabilities, and right now we're working on a project to combine as much additive manufacturing data as possible. So data from the CAD model, from the FEM analysis, layer data, print data, manual measurements, non-destructive evaluation, and destructive techniques in order to pull all that data together and evaluate the part and determine the best orientation for printing to manufacture the most durable parts that we can. So there is a question of you want to print a given part, and you have a design, you send that to the printer and it creates your part. How do you know that what you printed is actually what you wanted? That's a big question we're trying to answer with our evaluation process.
So some of the risks that come with this type of technology is understanding the material. Are you using properties that are based off of bulk extruded material in the case of a polymer? Or are you using material properties that you're testing from the printed component? And that's where aerospace is providing some value, is investigating not only just the process of printing these 3D printed products, but also understanding the material's characterization and also the dependency.
There are no widely accepted standards that would allow somebody to say, design a part using additive manufacturing and go out and build it and be confident that the process will work and the part will be of sufficient quality to accept for a space flight system. What aerospace can do is look at the applied aspect of additive manufacturing and I think undergird it with a broader and more fundamental understanding of the material science behind it.
We're exploring ideas about how to check something as we're building it without disturbing the powder, without disturbing the build in a way that might then cause defects. So we're trying to do it as carefully as possible to generate a portfolio, a file, if you will, to ensure that when we're done with this part, we can guarantee that it's got the right material, the right alloy, no porosity, or what we call our defects.